Okay, so before we finish our last lesson for Standard 14, let's review the scale, okay, for calculating area for 2D figures. Okay, you're at the beginning level if you can calculate the area given the required information for a rectangle, triangle, regular, pentagon, and circle. Okay, you're at the approaching level if in addition to that, you can calculate the area in two of the following scenarios. You can find a regular polygon with a missing apothem or side, find the area of a regular hexagon with a missing apothem or side, or a triangle with a missing height or base. Okay, and then you're considered proficient if in addition to level 1 you can calculate all of those three. Okay, so level 4 you can achieve by being proficient and then also being able to find the area of a shaded region involving more than one shape, okay, which we did in the last lesson with the pentagon and the circle. Or you can find the area of a composite figure formed by more than one shape, okay, which we've done as well in the last lesson with the we've done it with the rectangle and the semicircles on each end. So we've touched on all of that already. And the last part is the probability, okay? And I think that scale actually will be changed just a little bit because of the probability has to be worked in there yet, okay? So, finding geometric probability, okay? First of all, the probability of something is the likelihood or chance a particular event occurs. It's the chance or likelihood of an event happening. For example, if you roll a die, there's numbers 1 through 6 on a die, so the probability of getting a 2 is 1 out of 6 because there's 1, 2 out of the 6 sides, for example. Okay, so it's the probability that the number of successful outcomes over the number of total possible outcomes. Okay, so you can write it as a fraction or you can write it as a percent or a decimal. Okay, so here we talk about the decimals or fractions. Probability should always calculate to be between 0 and 1 as a decimal, okay, or a fraction. When writing your answer, either round to 4 decimal places or reduce. Okay, 4 decimal places or reduce. Okay, for percentages, okay, remember a decimal goes to a percentage by moving the decimal 2 to the right or multiplying by 100. Okay, probabilities written as a percent should always be between 0% and 100%. So 0% chance of rolling a 7 on a 6-sided die is 0%. Okay. When writing your answer, round to 2 decimal places. And that's why you go out 4 decimal places if you write it as a decimal, because then you could write it 2 decimal places out as a percent. Okay. So for example, consider each of the following situations, okay? The probability of getting tails when you flip a coin. So there's only a heads and a tails on a coin. So the probability of getting a tails, there's only one tail, and there's only 2 possibilities. So 1/2 as a fraction, 0.50 because it's exact, okay? Or a 50% chance of flipping a tails, okay? Probability of rolling an even number on a single roll of a 6-sided die. So again, remember numbers are 1 through 6. So how many of those are even? 3 out of the 6. 3 are even, 6 total possible. So reduced is to 1/2 again. So either 50% or 0.50 since it terminates. Okay. So the geometric probability is still the chance a particular event occurs, or likelihood, okay? So it is still the chance a particular event occurs, or you could say likelihood. You find that probability by finding the area of the requested region, so the area that they're asking you to find, the probability they're asking you for, over the total area of the region. So just like always in a fraction, the denominator, the bottom number is always your total. Okay? So let's look at what that looks like. If you're asked to find the geometric probability for each of the events described below. Okay? So this tells us that the diameter of the target shown is 80 centimeters. The diameter of the bullseye is 16. Okay? If an arrow hits the target and is equally likely to land on any point, what's the geometric probability that it lands in the bullseye? Okay? So the amount requested is the center, it's the area of the bullseye, the small circle. Okay? And the diameter is 16 centimeters on that, so the radius is 8. Okay, so 8 squared times pi, or 64 pi. Okay, and the area of the large circle is the total area possible, right? The whole target is all a possibility. Okay, and that is 80 centimeters for diameter, so that means 40 is the radius, so 40 squared over pi, or 1600 pi. Okay. So our fraction for that would be 64 pi over 1600 pi. So pi's cancel, right? Pi divided by pi would be 1. Okay, so 64 over 1600. Okay, as a reduced fraction, goes down to 1 over 25. It didn't tell us how to write it, so let's do it in all three. Okay, as a decimal, it's 0.04, and as a percent, that would be 4% chance of hitting the bullseye. Okay, second part of the question says, what's the geometric probability that it misses the bullseye, so it hits anything else outside the bullseye? Okay, well, if the probability of it hitting the bullseye is 0.04, of it not hitting, that'd be 1 minus 0.04 or 0.96. So as a fraction again, it could be 24 over 25, 0.96 or 96% chance of not hitting the bullseye. Much higher percentage, right? Okay, so let's look at the next page and finding some different probabilities here. Okay, we've got 3 more examples to work through here with probability. Okay, so to start with, find the geometric probability that a randomly chosen point in the figure lies in the shaded region. All right. So this was missing a number here. There should be an 18 down here. This one is 18 long. Okay. So the total area of the rectangle would be 18 times 12. And that is 216. Okay, so we have to, though, take out those circles, so we have to find the area of all 6 circles, okay? So if I divide, there's 3 circles here, and this is 18 long, so if I divide them by 3, their diameter is each 3. Each 6, because I divided by 3, which means my radius is 3. And if you went the other way with this 12, there's only 2 circles this way. So if you divide 12, that would give me a diameter of 6 also. Okay, so that is accurate. So the radius is 3 in each circle. Okay, so my area for one small circle is 3 squared times pi, or 9 pi. And I have to multiply that by 6 because I have 6 of them, so 54 pi. Okay, so my total possible area on the entire rectangle is 216. But for the top, I have to find the shaded part. The shaded part is the 216 minus the circles of 54 pi. Okay, so throw in 216 minus 54 pi gives us about 46.35. Just leave that answer in there and then divide it by 216. and I get as a decimal 0.2146. As a percent, that means it would be 21.46%. We're not going to leave it a fraction because we have a decimal in our fraction. We can't get it exact since we had to round with pi in there. Okay. Again, you think you got it, go ahead and give it a try. You can pause the video and give her a try. Okay. So, next one, find a geometric probability. Randomly chosen point in the figure lies in the shaded region. So just this little bit of shaded region outside here. So to start with, I find the area of the circle. So it would be 49 pi, because my radius is 7. Okay. And then for the next part, I have to find the area of the hexagon. Okay. So my hexagon, here's my triangle. I've got 7 here, so remember, I need to find my apothem. Since it's a hexagon, I know it is 60 degrees inside each central angle, so that's 30 degrees. So let me pull out my right angle here, my right triangle. So I've got 30 here, 60 here. So if I know my hypotenuse is 7, okay, then I know I've got 3.5 here. Because of 30, 60, 90, remember, I've got 3.5 on this side, and this one would be 3.5 square root of 3. Okay, so my height is 3.5 square root of 3. The length of one side here, we got 3.5 down here, so the whole thing is 7 times 6 gives me 42 for the perimeter. Okay. So remember then for the hexagon, area of the hexagon, I take my perimeter times my apothem divided by 2. Okay, and that should give me 73.5 square root of 3. Okay, so the area of the entire circle is my denominator, 49 pi. And to get the shaded part, I take my 49 pi and I subtract the hexagon, 73.5 square root of 3. And again, I'm not going to be able to get an exact fraction. That would be it, right? And so instead, what we're going to do is throw in 49 pi and subtract 73.5 square root of 3. And take that answer and divide it by, make sure you put in parentheses the 49 pi. If you don't put it in parentheses, it will divide it by 49 and then multiply it. So I get approximately 0.1730, 4 decimal places, which would be the same as saying 17.3% chance of hitting the shaded region. That's just these little parts outside here are the shaded. Okay, outside the hexagon, but inside the circle. Okay. And the last one today, okay, the shaded part is the two triangles. Okay, so to find the geometric probability that a randomly selected point lands in the shaded area, so that's these two, okay? So these are 8 all the way around, okay? This is saying this is 12, so that's saying that this is 12, so I can get my rectangle is 4 times 12, or 48. Okay, and then to get my height, so I can find my triangle area. I can take, that's half, so that's 6. Okay, so my height is 6 squared plus h squared equals 8 squared, so 64 minus 36, I get h squared equal to 28. If I square root both of those, I get do your factor tree, so 4 times 7 and 2 times 2. To be exact, I would say it's 2 square root of 7 for my height. Okay, so the area of the triangle, one triangle, is the base times the height divided by 2, but I do have 2 of them, so I'm going to multiply by 2. Okay, which means those guys are going to cancel out, right? So I have 24 square root of 7. Okay, for the area of the two triangles. Okay, so my total area of the whole thing is going to be 24 square root of 7 plus 48, right? I need the rectangle and the two triangles. That's the total. Okay, and the shaded part is just the area of the two triangles, which we got to be 24 square root of 7. Okay, so again, if I throw in my calculator again, put parentheses around that when you put it into your calculator, then you can enter it all at once. And you should get 0.5695, which would then be 56.95%. That's a little tougher one. We don't have, this is a hexagon, but it's not a regular hexagon, which means all 6 of the sides are not the same. So we don't find it the way we were able to find the pentagon up above, because it was a regular pentagon. Okay, so you should now be able to go ahead and complete your homework assignment on geometric probability.